Alrighty, folks. We are going to go ahead and go through the Kahoot for work, power, and energy. And I am going to be playing as Inspired Turtle. All right, let's go ahead and get started. So, we are talking about work, power, and energy. Question 1, in which scenario is work done? So, in order for work to be done, you have to be applying a force and moving the object in the same direction of that force. And so that means that lifting an apple is going to be the correct answer. Balancing a book, holding a puppy, and holding a barbell, all of those things are going to involve the object staying stationary, and so there's no movement. In order for work to be done, you have to have force and motion. All right, next up. A hammer weighing 20 newtons is lifted 5 meters. How much work is done? So we've got our formula triangle right here. We have 20 newtons, which is a force, 5 meters, which is a distance, and that means we're solving for work. We cover up the top here, the work, and we have force and distance side by side, meaning we multiply 20 by 5, and Newton meters becomes joules. So 20 times 5 is 100, and our unit is joules. Remember, you need to work for your joules. All right, next up. Which would increase power? So, power is going to be based on work and the rate that work is done. And so, that means that you need to do more work in the same amount of time, or you need to work faster. Working slower or doing less work in the same time would be lower power, and not doing work is no power. So think about a person shoveling a driveway. There's a certain amount of power required to do that, and so, or there's a certain amount of work involved with that. And so the way that the person can increase their power is by working faster or shoveling more of the driveway in the same amount of time. So if you think about just a driveway, a person is low power and can shovel it in, let's say, 30 minutes. If that person has a snowblower, that's more powerful than the person, and it does it in less time. And a snow plow, which is even more powerful than the snowblower, can do it in maybe a minute or two. All right. Next up. Raheem does 30 joules of work moving a bag of groceries in 6 seconds. How much power did Raheem use? Alrighty. So we have our power triangle right here. And so joules is going to be our work, and 6 seconds is our time. Work divided by time. So 30 divided by 6 is 5, and the unit for power is watts. So 5 watts is going to be your answer. All right, next up. A motor spins a shaft which rotates a carousel. What kind of what kind of simple machine is a carousel? Well, because you have a shaft spinning in the middle of the carousel and then the larger outside wheel of the carousel moving, that means that you have a wheel and axle, which are 2 discs or cylinders connected that rotate together. All right, next up. A motor spins a shaft which rotates a carousel. What kind of mechanical advantage does a carousel have? Well, because the motor is spinning the shaft or the axle, that means that the axle is moving the wheel. And so what that means is that the motor is moving the axle, which is the smaller cylinder in the middle here, and that moves a smaller distance while the outside moves a larger distance. So we are actually increasing distance, which means that you would have decreased force if you are rotating the axle to move the wheel. If you were doing it in reverse and we're moving the wheel to rotate the axle, you would have increased force and decreased distance. But this example, increase your distance. Next question. Which of the following is an example of kinetic energy? So kinetic energy is going to be the energy of motion. So we have a couple of examples here from a race. And so this is going to be the runner crossing the finish line of the race, because at the starting line, the runner is stationary. Taking a break during the race, that would be stationary as well, and laying down after the race is also stationary. So all those would be not kinetic energy, but potential energy, whereas crossing the finish line, they are in motion, therefore kinetic. Which pendulum bob has the most potential energy? So in this case, potential energy is going to be related to height and gravity. So you need one of the highest pendulum bobs. So it's either 1 or 5. But since 1 is where it starts, this is going to lose some energy as it travels just due to air resistance. So 1 is actually higher than 5, meaning it has the most potential energy. Alrighty, next up. The blank energy in a battery is converted to electromagnetic energy. So we have a battery, it's placed in a flashlight, and then it is converted into electromagnetic. So how is the energy stored in the battery? That would be chemical energy. Nuclear energy comes from the nucleus of atoms, and as far as I know, there's no such thing as a nuclear battery, and if there is, it's probably illegal. Thermal energy is the energy of heat. Electrical energy, the battery converts its chemical energy into electrical energy, which then is converted into electromagnetic, but in the battery, it is chemical. All right, next up. Energy resources such as water, geothermal, and solar are all this type of resource. And that because water, such as tidal energy, geothermal, which comes from the heat of the earth, and solar, those are all renewable sources of energy because they just naturally occur and are just part of the natural existence of the planet and the sun and the universe. So there you go, folks. That is your review for the Kahoot. Happy studying.